Hi there, welcome back to thinktankonlinelearning. So in this video, we're going to solve differential equation using Laplace transform. Okay, so these are partial differential equations. Okay, so we're given that partial u partial x plus x partial u partial t is equals to 0. And also given that when x at the point x is 0, u is going to be equal to 0, and at the point 0t u is equals to t, and t is greater than 0. Okay, so now what we're going to do, since we're told that we're going to use Laplace transform, we're just going to transform each partial derivative. Okay, so we're going to transform everything on the left hand side, partial u partial x plus x partial u partial t. We're also going to transform everything on the right hand side, and in this case we have 0. Okay, so the other thing that you can do, you can just write this one, partial u partial x, just want to write it as ux, and partial u partial t, I'm going to write it as ut. Okay, so now I want to solve for u. As you can see, I want to find the function u. Okay, so now we know that the Laplace transform, you are going to take the Laplace transform of the individual term, and I'm assuming that you know the Laplace transform of a derivative and also know the second shift theorem. Okay, so for this one, for the first one, the Laplace transform of ux, this one is ux. Okay, since it's a function in terms of x and t, I'm going to write uxt is going to be, okay, so for this one we don't know anything, we just know that it's a partial derivative, so let's just write it as partial x, the Laplace transform of u xt. Okay, as you can see, this is what we've done. And now we're going to this one, partial ut xt, the Laplace of y prime is equal to s y s minus y0. Okay, so I'm going to use this. So what is going to happen here, we're going to have s times the Laplace of uxt, okay, and the Laplace of uxt minus 4y0, that is the initial condition, and in this case it's going to be ux0. Laplace transform of ux, Laplace transform of ux right here, plus, remember we have x here, we're going to factor out x, and we're going to have the Laplace transform of ut, and this one is going to be equal to 0. Okay, so now for the Laplace transform of this derivative, let's just call it ux bar, right, plus x, and here we've said s ys, that is the function, we're going to call it u bar, minus y0, which is x0. What is x0? x0 is 0 right here, and I'm going to equate this to 0. Okay, and this one, let's just simplify it. I'm going to have xsu is equals to 0. Okay, so for this problem it's easy because we know this one is equal to 0, but let's say if this was equal to another function, it will become more difficult. So for this one, as you can see now, we have our linear first order ordinary differential equation. Okay, and I'm assuming that you know how to solve this problem. Okay, so first of all, we need to find the integrating factor, which is given by e to the power negative xs, that is going to be the integrating factor, and we're going to integrate with respect to x. And if we do that, we're going to get e to the power negative, and we're going to have negative x squared s over 2 right here. The solution will be given by u xt. We're going to put u bar here, will be equal to, we're going to choose a constant. Okay, so I'm going to, let me just choose a s, since it's going to be a constant function of s, and times the integrating factor. What is the integrating factor? It's e to the power negative x squared s over 2. I want to find the value of as. So to find the value of as, what are we going to do? We're going to use, we have u0t equals to 2. u0t equals to t. And we're going to use this to find as. So let's take the Laplace on each side. Okay, so we're going to take the Laplace of u0t. We're going to take the Laplace of t. And you're going to have, this is not Laplace, we're going to call it u bar 0. And for t, it's going to become s. The Laplace transform of t, we all know it's 1 over s squared. Okay, so by using this, let's just call this equation. Let's call it equation 1. And let's call this one equation 2. Okay, so now by using equation 1, you can substitute for u0. Okay, so here, this one is now, since we've taken the Laplace transform on each side, this one is now us. Okay, I'm sorry, it becomes us. So by using this, we know that u of 0s is going to be 1 over s squared. And we're going to substitute that here. And we know on this side, we're going to, let us write this, ux s is going to be as e to the power negative x squared s over 2. Okay, so by substituting this into this, or by using these initial values, you can see that right here we're going to have 1 over s squared, and here what we're going to have at x equals to 0, so we're going to have as e to the power negative 0 times s over 2, and this one is going to give us as. Okay, so now I know the value of as is equal to 1 over s squared. Okay, so since we now know the value of the constant, I think we're almost done. We have u xs bar is equal to, for as now we're putting 1 over s squared e to the power negative x squared s over 2. But we don't need u bar, or don't need the Laplace transform of this ordinary differential equation. I want to find the original. So we know that u will be equal to the inverse of u bar. That's how we can find this function. Okay, so now we're going to check the Laplace inverse on both sides of ux, and we're going to have the Laplace inverse of 1 over s squared e to the power negative x squared over s over 2. Okay, and from here we're going to use the second shift theorem, and I'm assuming that you are familiar with the second shift theorem. If you don't know it, go to the description, go to look for Laplace transform playlist, and we're going to find some videos who explain how to use the second shift theorem. Okay, but it's basically simple. What we're going to do is, if you want to find the Laplace inverse of e to the power negative as fs, that one is going to give us ft minus a ht minus a. Okay, you can use any letter, some may put g here. Okay, so from here we have e to the power negative as, and you know that our a is equal to negative as, so we have a, so our a is going to be equal to x squared over 2, right? And fs, what is fs? The coefficient of this is equal to 1 over s. So now let's find ft. So ft is going to be equal to the inverse of 1 over s. So the inverse of f is 1 over, so fs is 1 over s squared, and the inverse of 1 over s squared is equal to t. I think I've calculated it here again. Now the second shift theorem is very simple to use. What is going to be ux? Since it's now in inverse, we're going to have t here. Okay, so it's going to be f t minus a. So we have t right here minus a. Set a is x squared over 2. And we're going to have h times h. Okay, I've forgotten f here. And ht minus a is also t x squared over 2. Okay, and this is the solution for this differential equation. Okay, so you can write it as a piecewise function. It's also good. So thank you for watching. Don't forget to subscribe.